Okay, today we're going to start looking at polynomials and linear factors and zeros. In the past, we have written quadratic equations and factored them. We've had some practice with that. And when we do that, we have f of x is equal to x squared plus 3x plus 2. We now know that that is a second degree polynomial, and it's going to factor to x plus 1, x plus 2. If that equals to 0, then we can write it as two factors. X plus 1 is equal to 0, or x plus 2 is equal to 0. We use the multiplication property to know that if one of these is equal to 0, then the whole equation would be equal to 0. We find that x is equal to -1, or x is equal to -2. We call these linear factors. And any equation can be reduced into a string of linear factors. Or should I say, any polynomial that's factorable can be reduced to that. These linear factors give us the roots or the zeros of the function. And what that means is that it is the x-intercept. It is where it crosses the x-axis. Our factor theorem is that for f of x equals 0, any function equal to 0, the zeros or roots are the x-intercepts. Again, an x-intercept is where the line or the graph or the curve crosses the x-axis. So in x squared plus 3x plus 2 equal to 0, we know the factors again are x plus 1, x plus 2, and our roots are -1 and -2. What we do is we then graph it, and our zeros are where we cross the x-axis. We know that the vertex, because of the similarity of a quadratic function, that the vertex is halfway in between. And we find that it is at -1.5, -1.25. We see that we have a second degree polynomial, so we know that the function is even and that it will enter and exit the graph from the same direction. We also see that our coefficient is positive, so we know that it's going to go back we find out that we can factor most any polynomial if it is factorable. If not, then we have other ways of working with it. But any polynomial that has a graph that crosses the x-axis or even touches it is factorable to some point. That's why we're practicing on our factoring techniques. If you have x cubed minus 2x squared minus 15x is equal to 0, you know that we can factor it by first factoring out the x and then factoring the remaining quadratic. So we know that our x will equal 0, that our x will equal 5, or x will equal -3. Those are the zeros of our graph. That is where they cross the x-axis. Because it is a third degree polynomial, we know that it will be entering and exiting the graph from different directions. Because our coefficient is positive, we know that it will be falling to the left, rising to the right. Now we connect the dots and you see the general motion of the curve. It is not completely accurate because we're only sketching in between the first and the last zero. If you wanted to improve your efficiency or accuracy, then you would find points in between and graph them as well. This would allow you to find how high or how low each of those curves goes before there is a turnaround. So here, let's summarize how will you graph a polynomial. There are 5 steps, and they're quite easy. You're going to want to memorize these. Number 1 is to put your polynomial function into standard form. That means with your highest exponent to the left and in descending order. Number 2 is you're going to want to factor and find your zeros. Number 3, is the function odd or even? What does that mean to the graph? Number 4, is the leading coefficient positive or negative? What does that mean to your graph? Number 5 is to find points in between your zeros to help you know which way and how much of a curve you have. This helps you improve the accuracy. Now you just connect the dots. Following these 5 steps, you should be able to accurately sketch any of the polynomials that we do in the next few weeks. Sometimes you have factors or you have zeros, and then you want to find your polynomial and your function. We say that we know the roots and we need to find the function that goes with them. If we know that the roots of an equation are 2, -2, and 1, how can we find the polynomial? The first thing that we're going to do is write it out as a string of factors, remembering to use the opposite sign so that you'll have the correct factors. We have x minus 2 times x plus 2 times x minus 1. We'll FOIL the first 2 terms, and then we're going to FOIL the remaining terms. Notice when we do this that we're not going to be able to simplify, that this is already in standard form. Sometimes you can, sometimes you can't. Okay, so this would be the polynomial with roots of 2, -2, and 1. Are there more? Yes, there are more. You can multiply through by any constant and find some type of form of the polynomial. But in general, you'll just be multiplying through to get the initial polynomial. Sometimes you have roots that occur more than once. We call this a multiplicity of x or n. If I have a root that occurs 2 times, then I have a multiplicity of 2. If I have a multiplicity of 4 times, then it would just say multiplicity 4. All complex numbers have a multiplicity of 2. All complex numbers will have their conjugate part and have to be able to be part of your polynomial. And x to the 4th minus x cubed minus 10x squared plus 4x plus 4 equal to 0, we find that the roots are 4 in number. Notice that your highest exponent is a 4. That tells us how many roots we'll have. Our roots are x is equal to -2, -2, 2, and 3. We say that -2 is a root with a multiplicity of 2. Relative maximum and a relative minimum will occur in between your two roots when you graph them. We will use the graphing calculator to determine what the relative minima and maximum are. Here's an illustration of one. Just like in a quadratic equation or a parabola, you had a minimum and or a maximum. Each of these yellow boxes represent an area for a relative minimum and a relative maximum. Sometimes it's necessary for us to know what those are when looking at data so that we can go ahead and make conclusions. So again, when we have the graphing calculator, I will show you how to find those on your calculator. Here is your homework for your practice problems for the evening. I'd like for you to complete these in the practice section of your notebook, showing all your work. You can refer back to your textbook or your notes here to help you complete them.